If you were a PC gamer back in the 90s, you absolutely know Quake. It was a legend. But for decades, there's been this little piece of its history that's been a total puzzle. Tucked away with all the game files was one version that honestly just didn't seem to have a reason to exist. So today, let's finally solve the mystery of WinQuake.
You see, Quake wasn't just a single program. When you'd peek inside its folder, you'd find this whole family of different executables, and pretty much all of them had a very clear, very logical purpose.
You had your standard Quake.exe, right? The OG for DOS. Then there was vQuake.exe, built for a very specific 3D accelerator chip. You had GLQuake.exe for all the new OpenGL hardware, and of course QCCL.exe, which was the gateway to Quake World's mind-blowing online multiplayer. Each one made perfect sense. But then there was this one, WinQuake.exe. And you just had to ask, why? I mean, the original Quake.exe already ran just fine on Windows 95. So what problem was this new version even trying to solve? Well, that question, my friends, is why we're here. And the answer is just fascinating. To really get why WinQuake had to be created, we gotta rewind the clock. We're going back to the mid-90s, a really weird time when PC gaming was stuck with one foot in the old world of DOS and the other in the brand new world of Windows. Okay, so check this out. This chart is our first big clue. If you ran the original Quake.exe in pure DOS, you'd be cruising along at a slick 48 frames per second. But, and this is the crazy part, if you ran that exact same file inside Windows 95, your performance just cratered down to 38 FPS. That's a 25% performance hit. In a game as fast as Quake, that is a huge deal. So what was going on? Why the massive slowdown? Well, it's because Windows 95 didn't really run DOS programs. It sort of faked it. It ran them inside this little virtual machine called the DOS box. And while it was clever, all that extra translation for memory and system calls just added this layer of gunk that slowed everything down. So id Software was staring down three major problems. First, that 25% performance drop was just completely unacceptable. Second, getting online was a total nightmare because you needed this clunky software bridge to get the game in its little DOS box to talk to the internet. And the real kicker? The original game was completely, totally incompatible with Windows NT, the beefier, professional version of Windows. We're not talking about a minor bug here. As one of the developers, Charles Sandman, pointed out, a really fundamental way the game managed its memory, using something called near pointers, it just plain broke inside NT. It was a complete showstopper, the kind of problem that led to some very serious phone calls with Microsoft. The old DOS version had hit a dead end. A native Windows version was the only path forward. And so the mission was clear. id Software had to build a proper native Windows version of Quake. The goal? Fix all those compatibility and networking issues, and most importantly, claw back every single frame of performance that Windows had stolen. And man, did they succeed. Just look at these numbers. WinQuake, running in its best modes, hit 45 frames per second. They got back almost everything they'd lost, coming within just 6% of that pure, raw DOS speed. It was a massive victory. But how on earth did they pull it off? The secret sauce, the real genius behind it, was this incredibly flexible architecture. Instead of locking into one way of doing things, WinQuake was built with a modular system of backends. Think of it like snapping different Lego bricks into place, for video, for sound, and for controls, depending on what worked best on your specific computer. Take audio, for instance. You, the player, got a choice. You could use the new direct sound system for super low latency. You hear the rocket the instant it fires, but that would cost you a few frames per second. Or you could flip over to the older WinMM system, get a nice 10% speed boost, and just live with slightly delayed audio. It was all about putting the control in your hands. Now, the video options were where things got really interesting. The default, safe option was GDI. This was the standard, by-the-book Windows way to draw stuff on the screen. It was guaranteed to work, and it was the only way you could play Quake in a window on your desktop. The big downside? Oh yeah, it was also the slowest. The next step up was Direct Draw. This was Microsoft's official answer for high-speed gaming graphics, and it was a huge improvement over GDI, for sure. But it wasn't perfect. It could only run full screen, and it totally depended on the player having DirectX installed, which back in the 90s was definitely not something you could take for granted. But id Software wanted more. For the absolute bleeding edge maximum speed, they went outside the box. They actually licensed this incredibly powerful and probably very expensive third-party graphics library called Cytec MGL. This was their secret weapon.
All right, so now we get to the final piece of this puzzle, because that third-party library held the key not only to WinQuake's incredible performance, but also to its surprisingly long life.
So, hold on a second. This brings up a huge question. The whole point of an operating system like Windows was to stop programs from just directly messing with the hardware. It was supposed to create a stable system. So how in the world could this MGL library give Quake that raw, direct, DOS-like speed? Wasn't that totally forbidden? Well, the answer was a piece of tech that felt like pure black magic. It was called WinDirect, and this was Cytec's crown jewel. It was this little piece of code that could basically walk up to Windows and say, "Hey, you, stand back for a minute." It would completely shut down the standard Windows graphics system and let the game take total direct control of the video card, just like the good old days of DOS. I mean, listen to how the original programmer's guide describes it. WinDirect literally breaks this barrier, letting a Windows program act like a DOS program, taking over the hardware completely. It was such a clever, such an audacious hack. So let's trace the path here. It's brilliant. WinQuake makes a call to the MGL library. MGL then uses its secret weapon, WinDirect, to completely sidestep the normal Windows graphics system. This gives the game raw, direct access to the video hardware. And boom, that's how you achieve that incredible near-DOS level of performance. And now, for what I think is the most amazing part of this whole story. After all these years, after all those hacks and clever workarounds, you can take that original WinQuake.exe file, drop it onto a brand new Windows 11 machine today, and it just runs perfectly in windowed mode. So in the end, the mystery of WinQuake tells two incredible stories. First, it's a testament to the absolute genius of id Software's engineering, building something so flexible it could adapt to anything. And second, it's just a powerful example of Microsoft's unbelievable, decades-long commitment to making sure the software of yesterday still works today. It really makes you think, right? When you look at the complex, constantly updating apps we all use every single day, you have to wonder, which of them are being built with that kind of cleverness, that kind of robust design that will let them still function 3 decades from now? It's a pretty fascinating question to chew on.